In this lecture, I am going to talk about imaginary numbers. Before the definition of imaginary numbers, I am going to say why imaginary numbers when we got the set of real numbers. As we all know in the field of mathematics that the under root of a negative number is not possible, or you can say it is an error. Then a mathematician called Leonard Euler, he represents -1 under root with the letter I. So this is actually the definition of imaginary numbers. Now square this equation both sides. This is I square equal to -1. When you see this equation, the square of a number, we get the negative results. Let's expand this equation a little bit. I times I is equal to -1. When we multiply two same number in the field of imaginary numbers, we will get the negative results. Let us see in the field of real worlds. When a number is multiply itself, what we get? 5 times 5. Let's take 5. 5 times 5 equal to 25. This is positive. -5 times -5 equal to 25. This is again positive. 0 multiply 0. This is 0. This is neither positive or negative. 0 is 0. In the field of real numbers, when a number is multiply itself, we will get the positive results. But in the field of imaginary numbers, when a number is multiply itself, we will get the negative results back. So that's why it's called imaginary numbers. When a number is multiply itself, that can only give us negative results back. Let us see other powers of I. I raised to the power 0 is equal to 1. You know anything raised to the power 0 is equal to 1. So I raised to the power 0 is equal to 1. I raised to the power 1 is equal to I. I raised to the power 2 is equal to -1 from this equation. I raised to the power 3 is equal to I raised to the power 2 times I raised to the power 1. I raised to the power 2 equal to -1 times I. This is equal to -I. I raised to the power 4 is equal to I raised to the power 2 times I raised to the power 2. Bases are same, powers are added. I square equal to -1 times -1. This is equal to 1. I raised to the power 5. This is equal to I raised to the power 4 times I raised to the power 1. Bases are same, powers are to be added. This is equal to I raised to the power 4 is equal to 1. I raised to the power 1 is equal to I. This is equal to I. So I raised to the power 0 is 1. I raised to the power 1 is I. I raised to the power 2 is -1. I raised to the power 3 is equal to I minus I. I raised to the power 4 is equal to 1. I raised to the power 5 is equal to I, and so on. So you can expand more and more this way. Let's take one more example. -16 under root is equal to, I can write 16 times -1 under root. I can break it down with the negative number. This is equal to 16 under root times minus 1 under root. As you know, the law of a radical m times n under root equal to, can be written m under root times n under root. This is the law. This is the law of radical. This is our m and this is our n. They both can be written separately. 16 under root is 4 minus 1 under root. This is actually our definition. This is 4i. So minus 16 under root is equal to 4i. Let's take one more example with the square. 5i square. This is equal to 5 square times I square. This is equal to 5 square is equal to 25 and I square. I square is equal to minus 1. 25 times minus 1, this is equal to minus 25. So 5i square equal to minus 25. This is pretty much all in this lecture. In the next lecture, I am going to take more imaginary numbers. So this topic can be expanded more and more. And the concept of complex number I will take in the next 2 lectures. That's all in this lecture. Thanks for watching.